Alright, let's begin. So to quickly cover things from the past weeks, I no longer do the decrement as part of the conditional for the inner loop for collision self. Now instead we do it as part of the inner loop's iterator. So now the inner loop starts at the end of the collision self list and works its way backwards to meet the iterator from the outer loop, and that will guarantee we never have crashes. For the sprites itself, I still can't get the origin to work properly. I'm not sure what part of the math I'm doing incorrectly, but right now I'm trying to move everything to the origin space, compute the matrix, and then move it back to this position in the world, but it still looks wonky, so it's not going to look correct in the beginning of the project. So on that, let's begin. For this week's assignment, we had to do sprite strings as well as screen logging. So as you see, we have two sprite strings here, one of which using the tab key. And then we also have this screen log that updates both its position and the y value based on the y value of the cube. So as you see, as the cube increases y value, so does the number, and as it decreases, the number decreases as well. The leaks for creation of the SpriteFont, we take in the key value for the string and then the path. So the name becomes the key. We load into the texture singleton using that key that we just got, and then we add the TGA value to the path. That makes us make sure we find the texture, and then we make the texture for the SpriteFont what we just created, and then we take that path and add the XML so that we can analyze the XML file. So for the analysis, we create a new image. The name of the image is the name plus the character of the ASCII value. Take in our current font texture, and then give the rectangle that's X, Y with height of the ASCII that we just collected. So all the values that we got above creates the rectangle. For our sprite, we check for the location the key that we just made, and that gives us each of the individual text characters. Then we push it into the font map. Once all that's said and done, we do it one more time here just to add in the tab value. So if I were to quickly go over to showcase this, you can see that we have the tab key right there. For the sprite, and then for getting the glyph, we take in the character and convert it to its ASCII value for finding its location in the map. For SpriteStrings, setting the collection, we take in a given font. That's now the font for the sprite string. We take in a given string, and then once we have our string, we iterate through it, find the glyph with each given character in the string, and push it onto a collection. Increment the width based on the newly acquired sprite's width value, and then move on to the next character. Height we only have to set up once because all of the text characters in the TGA file have the same height, so by doing it once we get it for everything, and then we set the X and Y. Updating the collection, we just empty out the collection and then reset the collection once again with a new string. For rendering, we loop through our entire collection, set the position to be an X and Y offset, render it, and then increase the X offset by the width value. And then we move on to the next glyph. For the screen log, we have a command pattern set up similarly to how the visualizer is set up, where we create a new screen log, and if we have a spare one in the command pool, we just initialize from the command pool. So the commands, when we create a new one, we create a new sprite string. When we initialize it, we just update the string to be the new texture, or the new string specifically. So see here with the cube, we add logs in the update just to showcase we can do it whenever, or wherever we want specifically. When it's time to render the logs, we iterate through our active commands, render each of them, and then push them into the command pool before popping them off the list. Then when it's time to unload, we unload all the active commands, and then unload all the command pool, and then delete the pointer instance. For the kitchen itself, also actually for the font texture, just a quick show, we are using the tab key. For this, we have the attorneys to pass through the preload and unload content for the font manager, as well as also, if we go over here, we have the setting the defaults for the screen log, and for drawing, we have the screen log at the start of the draw. And when it's time to unload, we have the SpriteFont and the screen log unloading as well. For the tank demo, I didn't have much time to work on actual mechanics, so I just focused on making a HUD. So this HUD updates based on the current count of enemy tanks. So as you see here, it's going to go up now that the tanks are respawning. Has some standard controls on the title screen. Then if I press P to swap scenes, we can see now we're in the second scene, which once again, it updates based on how many of the purple tanks are on the screen. So once they start respawning, we see that number goes up. For actually coding that, for the HUD, we have a red tank alive text, purple tank alive text set up. and then we have an update parameter to set up whenever a tank is created or destroyed. In the tank factory, like I said, whenever a tank is created, revived, or destroyed, we either increase or decrease their counter and then update the text string appropriately. And when we run out of lives, we go over to a game over screen that tells us to press R to return us back to the title screen. And no leaks. The last thing, I didn't have time for documentation again, which is really bad, I know, but I did have time to set up the framework this time, so I do have the basis to actually begin doing documentation now. And that's it.